Hi everyone, we are now in Form 4 Additional Maths, Chapter 9 Differentiation, where we are looking at the part rates of change. So before we start, we need to look at the chain rule, where we learned that any derivative of y with respect to x, dy dx, we can also write it in the form of this dy here, we write dy multiply, and the dx, we write it here, where this part and this part, we can write another unknown. Like for example, dt, there must be the same unknown. Given dy dx is 10, dx dt is 5 units per second. So the t here represents time. So here is second. Find dy dt. So according to chain rule, we know that dy dx equals to dy over, so in this case, since t is involved here, so we take dy dt multiply dt over dx. Okay, dy dx dx, and here we just replace it with the third quantity. In this case is t. Then we try to fill in the values. Given dy dx is 10 means this is 10. Dy dt is what we are looking for, so we just rewrite it here. Dt dx is this, but inverse form. You see dx dt, this is dt dx. So we can just write this, which is given as 5 units per second, in the inverse form. Since this is inverse, so we write it 1 over 5. Then we just solve this. In order to find dy dt, we just move the 5 here. You get dy dt equals to 10 times 5, which is 50. So if you want to know what's the units, is it dy? We don't know what is the unit, so it's just units. T is time, given here, so it's units per second. But you don't have to include units as a final answer for this case. Question 2. Given y equals to 3x squared minus 2, if the rate of change of x is 2 units per second, find the rate of change of y when x equals to 2. Rate of change, find the rate of change of y. Means dy, rate of change is dy dt. This is what we are looking for. So usually when a question involves rates of change, usually we use the chain rule to help us to find the answers. Okay, and so here rate of change of x is dx dt, which is 2. Now if you use the chain rule, dy dx equals to dy over dt times dt over dx. Dy dt here is the one we are trying to look for. Dx dt we can get from the inverse of dx dt, so no problem. But the problem is we don't have the information for dy dx. Hence, we have to find dy dx by ourselves by using the given equation here. So given here x is equals to 2. Since we will need the value, so we need to substitute x with 2. You get 6 times 2, you get 12. So now we have the value of dy dx, which is 12. We substitute all the values inside, so this is 12, dy dx units per second. Number 3, question number 3, the area of a square increases at the rate of 12 centimeters squared per second. Find the rate of change in the length of its side when the area is 4 centimeters squared. Okay, so we look at the information first. Area of a square increases at the rate, so it's a rate. So area of a square, if let's say we let this a, hence 12 here is actually dA dt, because it's a rate, so it's over dt here. Okay, so now we have dA over dt is equals to 12. Find the rate of change in the length of its side. So since we don't know what is the length of the side, we let this becomes an x. So the rate of change of the length of this x becomes dx dt. So if we let x equals to length of its side, hence we are looking for dx dt. And again we are given the area is 4, means we know that A is equals to 4 centimeter squared. So if you want to use the chain rule, we have dA dt, we have dx dt. What is the one which is missing? Look at the two quantities here. One is area, one is the side. So we need to find dA dx or dx dA. In order to find dA dx, we need to first find the relation between A and x before we can differentiate it. So the area of a square, how do you find the area of the square? Area of the square is equals to the square of its side. So the square of its side is x squared. So now we have the relation between A and x. We can find dA dx, which is 2x. Since we want to find the value of this, we need to get the value of this first. In order to get the value of x, we need to use this. The area is 4. When area equals to 4, the length of the side is equals to the square root of the area, which is the square root of 4. In this case, there will be no positive negative because the length of the side is always a positive value. So answer is 2. Hence, we know that x is equals to 2. Hence, dA dx equals to 2 times 2, which is 4. Now we use the chain rule. We can take dA dx equals to dA. Here we put dt, multiplies, dt again must be the same, and here is dx. dA dx, we get the value of 4 from here. dA dt, we get the value of 12 from here. dt dx is the one that we're looking for, dt dx. But the question asks for dx dt. Find the rate of change in the length. So dx dt equals to 1 over dt dx. 1 over 3, which is equals to 3. Question number 4. If the radius of the circles is decreasing at the rate of 0.3 meter per second, find the rate of decrease of the area of the circle when its radius is 4 centimeter. So here we have the first information. The radius of the circle is decreasing at the rate of this. So if a radius, we use r, rate, so it's dr dt. But since it's decreasing, so we need to use negative to denote the decreasing part. So it's a 0.3. Find the rate of decrease of the area of the circle when its radius is 4. So now the question asks us to look for the rate of decrease of the area of the circle. Means if we let A equals to the area of the circle, so dA dt. Again, see, since we have already t here, we need to find the relation between A and r in order to find dA dr. So since this is a circle, area of a circle is equals to pi r squared. We find dA dr, which is 2 pi r. When the radius is 4, r is equals to 4, so it's 4 times 2. Okay, so it's 4, hence you get 8 pi. So now using the chain rule, dA dr equals to dA over dt times dt over dr. Since the r is here, dA dr is 8 pi. dA dt is what we are looking for. dt dr is the inverse of dr dt, so it's the inverse of negative 0.3. So the negative here shows that it's decreasing. So what does this mean? It means The area of the circle is decreasing at a rate of negative 2.4 pi centimeter. Sorry, it's meter squared per second. If you're not sure about the units, I advise you not to write down the units unless stated. Question number 5. The volume of sphere increases at a rate of 3 cm³ per second. Calculate the rate of change of the radius of the sphere at the instant its surface area is 100 pi cm². Volume of a sphere, so it's V at a rate dV dt, 3 cm³ per second. Calculate the rate of change of the radius of the sphere. So you find dr dt when the area is 100 pi. So since we already have dV dt and dr dt, we need to find dV dr or dr dV. So the first thing, we need to relate V and R. Volume of a sphere, according to the formula, is equals to 4 over 3 pi r cubed. To find dV dr, we find the first derivative of this with respect to r. So you get 4 pi r squared. Now we need to find the value of r in order to find the value for dV dr. So to find the value of r, we need to use this information when the surface area is 100 pi. So the surface area of a sphere is given by the formula 4 pi r cubed. So when the surface area is 100 pi, what is the value of r? We solve this. Okay, so we try to solve this. I think I made a mistake. It's supposed to be squared. It is squared. So it's squared here, 4 pi r squared. So in order to find r is the square root of 25, which is equals to 5. No need there's only a positive value because radius is always positive. So now we know r is equal to 5. This will be 5, so it's 4 pi 5 squared. 5 squared is 25. 25 times 4 is 100 pi. So actually, you'll find that this is the same value as the surface area because dV dr actually represents the surface area. Now we have all the values needed. We just use the chain rule. dV dr equals to dV over dt times dt over dr. dV dr is this 100 pi. The inverse, since we are looking for dr dt, so we are looking for the inverse of this. So dr dt is equals to 3 over 100 pi. That's the answer.